Okay, we're back with the Chem 4 review for final, and we're up to video number 4, which is called Tricky Molarity Problem. It's tricky because you're actually going to have to use both lifesavers in this problem. And here's the problem. If you have 159 grams of the K2 compound, they give you the molar mass, in 150 grams of water, and the density of the solution, and that's important, is 1.2 grams per milliliter. What is the molarity? The first thing we do, I made a little drawing with density, solute, and solvent. The second thing we do is write the formula for molarity. Molarity is moles over liters. Here's our first lifesaver. Moles is mass over molar mass. Now, a smart idea on your scrap sheet might be to write molarity equals mass divided by molar mass over our second lifesaver. Here's our second lifesaver. Density of the solution equals mass of the solution divided by volume of the solution. And solution's a key word. We're going to solve in this problem, we're going to need the volume of the solution. So we're going to rearrange lifesaver number 2 for volume. Volume equals mass over density. And make sure the key word is solution, so we need to do the solute and the solvent. So let's do this calculation first. Let's plug in. Molarity equals the mass we're given of the solute, 159.0 grams, K2Cr2O7, divided by the molar mass, which they gave us, 294.1846 grams per mole. When we divide that, we're going to get 0.5404769658 moles. Now let's look at the denominator. Now we have the moles, we need the liters. But when you look at this problem, you see the magic word density. If you see density, you've got to think lifesaver number 2. So what we're going to plug in here is the mass of the solution over the density of the solution. Make sure you do the whole solution. So we're going to divide by the mass of the solute, which they gave us, right here, 159.0 grams, plus the mass of the solvent, which is 150.0 grams, and we're going to divide that by density, and they gave us that at 1.20 grams per milliliter. Boop, boop, boop. But anytime you see milliliters, a little alarm should go off in your head, because down the road we're going to have to change that to liters. And when we add these two numbers first, hit enter, and then divide by 1.20, we get 257.5 milliliters. Well, we can't put that in as liters. We need to change the milliliters to liters. We're going to move the decimal 1, 2, 3. 0.2575. 0.2575 liters. Boom, there we go. This is a really good way to put the two lifesavers in. I suggest you do it in all these different forms, so that way you can use what you need. And when we divide those two numbers, we end up with 2.1032313. Remember, units for molarity could be capital M, or they could be moles per liter, or they could be moles, liters, to the -1. If you can do and understand both of these molarity problems, there's not a molarity problem you can't solve. Because this one, especially with the two lifesavers, is the worst possible problem you could face. And if you know this, and you know your options for figuring out moles and liters, there's nothing you can't solve. So we're gonna stop the video here, and we're gonna pick up with molality.